Hello everyone, welcome back to Physics online classes for class 12 students. Let us continue chapter 3, current electricity. Today we are going to study about parallel combination of cells. So in the previous class we already studied the series combination of cells. So here we know that when cell is connected in series, the potential difference increases, voltage increases when cells are connected in series. And also we studied the n number of identical cells when they are connected in series. So we derived an expression for electric current. And also we solved two special cases. Suppose if the external resistance is greater than internal resistance, whether current changes or whether it remains constant. Similarly, the second case, when external resistor is very small than internal resistor, then what are the changes occurs in the electric current? So that we studied in the previous class in detail. Now we can move to the next part, that is parallel combination of cells. So first we have to know what is parallel combination of a cell. You can observe this circuit diagram. We considered two cells. The first cell, it is positive terminal and this is negative terminal. Second cell, the first terminal is positive and this is negative terminal. The first cell is having EMF E1 and its internal resistance is R1. Similarly, E2 is EMF of the second cell and R2 is its internal resistance. Now A and B are the terminals. So here when we are going to consider electric current I, from positive terminal to negative terminal, the flow of electric current takes place. Suppose if the terminal A, if it is connected externally with the help of connecting wire, I am going to connect this terminal A to the external resistor R and another end is connected to the terminal B. You can observe, we already know that the flow of current takes place from positive terminal to negative terminal. So now we have to know what do you mean by parallel combination. So when positive terminal of all cells are connected together and negative terminals of all the cells are connected together, then the cells are said to be connected in parallel. You can observe positive terminal of the first cell and negative terminal of the second cell, both are connected to the common point A. Similarly, negative terminal of the first cell and negative terminal of the second cell are connected to the common point B. If they are connected to the common point, or if the polarities or the same polarities are connected to the single point, then we can say that cells are said to be connected in parallel. Yes, what do you mean by parallel combination? When a positive terminal of all cells are connected together and negative terminal of all cells are connected together, then the cells are said to be connected in parallel. Is it clear? Suppose the main current, if you are going to take I, so this main current I is divided. How it is divided? So here you can consider I1 current is flowing in this direction and I2 amount of current is flowing in the second cell or through the second cell. So the main current I is equal to sum of the branch current, that is I equal to I1 plus I2. I1 amount of current is flowing through the first cell and I2 amount of current is flowing through the second cell. The main current is I and it is flowing from positive terminal to negative terminal, that is point A to point B. Is it clear? Now these two cells are connected in parallel. Suppose instead of two cells connected in parallel, if you are going to consider equivalent cell, it is having the value of E1 and E2 together. Suppose if you are going to consider equivalent cell and this is having EMF EEQ and its internal resistor is, let us take it as REQ. This is equivalent cell. Is it clear? So here when you are going to derive the combination or the grouping of cells, that may be series or a parallel or a mixed grouping of cell, you have to know the definition of cell, EMF, internal resistance and terminal voltage. You already studied. Once again I will repeat. Cell is a device which converts chemical energy into electrical energy. EMF is potential difference across the terminals of the cell when the circuit is open. And third point, internal resistance, the opposition offered by the cell to the flow of current. And the fourth point, terminal voltage. This is the potential difference across the terminals of a cell when it is a closed circuit. The cell is having EMF E1 and E2. But when it is a closed circuit, when it is connected externally to the resistor capital R, then its potential difference decreases. We already studied. So let us take it as terminal voltage VAB, that is potential difference between the terminals A and B. So here we are going to consider terminal voltage where it is a closed circuit. Is it clear? So now we know that when the cells are connected in series, then its potential increases. Now the question arises, suppose the cells are connected in parallel, then what is the use? Whether potential increases here? No. Here EMF remains constant. EMF means what? Potential difference or voltage. So when the cells are connected in parallel, potential difference does not changes. That means EMF value does not changes. It remains constant. But the electric current increases. We can get more current, increase in the current when cells are in parallel. When cells are in series, we can get a large potential. So that means if you want to increase potential, go for series combination. If you want to increase current, then go for parallel combination. If you want to increase both potential and current, then go for both the combination, that is series and parallel. Now we can derive an expression for parallel combination of cells. So we considered two cells in parallel combination. So the first cell is having EMF E1 and internal resistance is R1, and the second cell is having EMF E2 and its internal resistor is R2. Main current is I, which is flowing from the terminal A to the terminal B, and instead of using these two cells, by replacing these two cells, we can consider a single cell, that is equivalent cell having EMF EEQ and internal resistance REQ. You can observe the points here. Let E1 and E2 are EMFs of two cells. R1 and R2 are internal resistance of the two cells. Then EEQ is equivalent EMF of parallel combination. Then REQ is equivalent internal resistance of the parallel combination. And I1 and I2 are the currents offered by the two cells. I is the current flowing through the combination. And at last VA and VB. So VA and VB, these are the potentials at A and B respectively. Is it clear? Now we can consider potential difference across the first cell, that is potential difference between A and B. So here for the first cell I can write potential difference between A and B of the first cell. Potential difference between A and B of the first cell is, I can write here VAB is equal to higher potential minus lower potential. So we can write in general VA minus VB. Or we can also write this equation as VAB is equal to, we already studied in the previous class. So here I can write E1 minus I1R1 because we considered two cells connected in parallel, E1 minus I1R1. Or we can write this equation as, we can take this minus I1R1 to LHS side, it will become plus I1R1, and we can take VAB to RHS side, it will become minus VAB. See here, I1R1 is equal to E1 minus VAB. Now I am going to write it as I1 is equal to, let us take it as E1 minus VAB divided by R1. Right? So I1 equal to E1 minus VAB divided by R1. Let us take it as equation number 1. This is potential difference between A and B of the first cell. Here we got the electric current flowing through the first cell. Similarly, we can write potential difference between the terminals A and B of the second cell. We can write for the second cell. How to write the equation? Again, we can write VAB is equal to VA minus VB, or we can write here VAB is equal to E2 minus I2R2 because this is second cell. Or we can also write this equation as, I am going to write here, I2R2 is equal to E2 minus VAB. So here we want the value of I2. So I2 equal to E2 minus VAB divided by R2. Let us take it as equation number 2. So equation number 1 gives the expression for I1. Equation 2 gives an expression for I2. Now how to write the total current? Total current is equal to, we can write total current is I equal to, main current is how much? I equal to what? The sum of branch currents or the sum of electric current passing through both the cells. I equal to I1 plus I2. Now remaining is only substitution. Substitute equation 1 and 2 here. I am going to write I equal to I1 means equation 1. E1 minus VAB divided by R1 plus I2 value, refer equation 2. E2 minus VAB divided by R2. We substituted equation 1 and 2 here. Or this equation can also be written as I equal to, see here I am going to write E1 by R1 minus, here I can write VAB divided by R1 plus E2 divided by R2 minus VAB divided by R2. Or we can take EMF and internal resistor on one side. So I can write this equation as E1 divided by R1 plus E2 divided by R2. Remaining is what? Minus VAB by R1 minus VAB by R2. So we can take VAB as common, minus VAB we can take outside. Remaining is 1 divided by R1 plus 1 divided by R2. Is it clear? Or I can write this equation as I equal to E1 by R1 plus E2 by R2. Let us take LCM. LCM we can get R1 R2. So in the numerator we can write E1 R2 plus E2 R1. Right? So we took LCM here. Remaining is what? Minus VAB. Here also we can take LCM is R1 R2. And in the numerator we can write R1 plus R2 or R2 plus R1. Right? Now I am going to write VAB R1 plus R2 divided by R1 R2. This term I can take on LHS side, it will become a plus. And I am going to take I on RHS side, it will become minus. See here I am going to write VAB R1 plus R2 divided by R1 R2 on LHS side. It will become plus. E is equal to E1 R2 plus E2 R1 divided by R1 R2. Keep as it is. We can take electric current I on RHS side. It becomes minus I. Is it clear up to this point? Now, we can write this equation as, yes, see here, the next step. See here, again I wrote the same equation here. Let us continue the next part. VAB R1 plus R2 divided by R1 R2. Here I am going to take VAB is equal to R1 plus R2 divided by R1 R2. This term I am going to take on RHS side. How to write the equation? See here. E1 R2 plus E2 R1 divided by R1 R2 minus I. So this is the value, keep as it is, multiplied by, so this term when we are going to take on RHS side, so I can write R1 R2 divided by R1 plus R2, right? Or we can individually multiply VAB equal to E1 R2 plus E2 R1 divided by R1 R2 multiplied by R1 R2 divided by R1 plus R2. Then next part, minus I into R1 R2 divided by R1 plus R2. R1 R2 by R1 plus R2 is multiplied individually. Now we can write VAB is equal to, here R1 R2 will get cancelled, so we got E1 R2 plus E2 R1 divided by R1 plus R2. And here we can write minus I into R1 R2 divided by R1 plus R2. So let us take this equation as 3, equation number 3. Is it clear? So this is for parallel combination. Now I am going to replace these two cells by a single cell. You can observe this diagram. Instead of taking this parallel combination for two cells, I am going to take this part. So replacing these two cells by a single cell having equivalent EMF EEQ and internal resistance REQ. Now we can find a potential difference between A and B. See here, I am going to write here, suppose if the parallel combination of two cells is replaced by a single cell of EMF EEQ and internal resistor REQ, then we can write potential difference between A and B is. Yes, tell me how to write potential difference between A and B for the equivalent cell. I can write potential difference between A and B means VAB is equal to VA minus VB. Or we can write VAB is equal to E equivalent minus I R equivalent. Let us take it as equation number 4. Now let us compare equation 3 and equation 4. Compare equation 3 and equation 4. What we can get? Observe equation 3 and 4. Equation 3 is for two cells connected in parallel. Equation 4 is for individual cell which is equivalent to parallel combination. Let us compare equation 3 and 4. So we can write the equation E equivalent is equal to, what to write here? So we can write E1 R2 plus E2 R1 divided by R1 plus R2. Let us take it as equation 5. Similarly, I can write REQ is equal to, compare equation 3 and 4. Observe carefully here, REQ equal to what? R1 R2 divided by R1 plus R2. Let us take it as equation number 6. Equation 5 is EEQ equal to E1 R2 plus E2 R1 divided by R1 plus R2, and REQ equal to R1 R2 divided by R1 plus R2. Is it clear up to equation 5 and 6? Now dividing equation 5 by equation 6. See here equation 5 and 6, you can observe E equivalent and R equivalent. Dividing these two equations, what we can get? See here, by dividing these two equations, we can write E equivalent divided by R equivalent is equal to, equation 5 is E1 R2 plus E2 R1 divided by R1 plus R2. Right here, E1 R2 plus E2 R1 divided by R1 plus R2. This is equation 5. Divided by equation 6. Equation 6 is R1 R2 divided by R1 plus R2. So here we can write R1 plus R2 divided by R1 R2. Dividing these two equations, so we can write E equivalent divided by R equivalent is equal to, here R1 plus R2 will get cancelled. Remaining is E1 R2 plus E2 R1 divided by R1 R2, or we can write this equation as E equivalent divided by R equivalent is equal to E1 R2 divided by R1 R2. Separately we can write the division here, E2 R1 divided by R1 R2. Again I am going to modify this equation. E equivalent divided by R equivalent is equal to, I am going to write this equation as E1 by R1, because here R2 will get cancelled and here R1 will get cancelled. So E1 by R1 plus E2 divided by R2. So let us take it as equation number 7. Now again you can observe equation number 6. Equation 6 can be rewritten as, equation 6 can be rewritten as, first you have to observe equation 6. Equation 6 is R equivalent equal to R1 R2 divided by R1 plus R2. So this equation can also be rewritten as, you can observe here only, I am going to write, I am going to make it reciprocal, 1 by REQ is equal to R1 plus R2 divided by R1 R2. It is just like a LCM. So we can write 1 by REQ equal to 1 by R1 plus 1 by R2. Observe here, what is the LCM? R1 R2. So we will get the same equation, right? So the same step I am going to write here. Equation 6 can be rewritten as 1 by REQ is equal to 1 by R1 plus 1 by R2. Let us take it as equation number A. Is it clear how to write the final equation? E equivalent over R equivalent is equal to E1 by R1 plus E2 by R2. This is for two cells. Or we can use equation number 8, that is 1 by R equivalent. For parallel combination, internal resistance is 1 by R equivalent equal to what? 1 by R1 plus 1 by R2. Suppose if you are going to consider n number of cells. For n number of cells, how to write equation 7 and 8? Equation 7 and 8 leads to the forms. That means equation 7 and 8 can be written as, see here, E equivalent over R equivalent is equal to E1 by R1 plus E2 by R2, so on up to En divided by Rn. So this is for n number of cells when they are connected in parallel. Let us take it as equation 9. Similarly, one more equation, 1 by R equivalent is equal to, we can write 1 by R1 plus 1 by R2 plus 1 by R3, so on up to 1 divided by Rn. So this is for n number of cells connected in parallel, that gives internal resistors. So this is the expression for parallel combination of cells. So equation 9 and 10, that gives EMF and internal resistance of two cells or n number of cells connected in parallel. So this derivation carries 5 marks. I will revise once again, you can observe. The first step, potential difference across the first cell and potential difference across the second cell. We got equation 1 and 2. This is the expression for I1 and I2. Second point, total current. I equal to I1 plus I2. Substitute here and we are go on modifying the equation. So here we got equation number 3. After that, we are going to replace these two cells by a single cell. So we got equation 4. Comparing equation 3 and 4, we got equation 5 and 6. Now I am going to divide equation 5 by 6. So finally we will get equation 7 and 8. This is only for two cells connected in parallel. For n number of cells, we can take equation 9 and 10. So this is the derivation or an expression for parallel combination of cells. So this derivation carries 5 marks.